Hello and welcome from us here at Inteletrack. This video will provide more detail on what our advanced end-of-train telemetry devices have to offer. An end-of-train telemetry system consists of an end-of-train device, commonly referred to as an EOT, and a head-of-train device, commonly referred to as an HOT. The EOT is mounted on the outside at the rear end of the last wagon of the train and is battery-powered. The HOT, on the other hand, is installed in the cab of the locomotive, where it is easily accessible and visible to the driver of the train. The basic feature of these devices is to monitor the air brake line pressure and keep the driver continuously informed about the pressure. The air brake line of the train is a continuous pipe that runs from the locomotive right through to the last wagon of the train. The brakes on each wagon are controlled by air pressure, which is generated by the locomotive and is supplied to the wagons by the air brake line. It is important to know that the default state of the brakes is a fully engaged state, when no air pressure is available. Only when pressure is resupplied to the air brake line will the brakes on each wagon start to disengage as the pressure rises. The brakes will only be fully disengaged when the pressure crosses a certain threshold, making it possible for the train to move again. The EOT at the back measures the air brake line pressure constantly and sends this information to the HOT in the locomotive. This information coming from the EOT displaying the pressure difference on the HOT in the cab will inform the driver visually and audibly. The display will confirm if the air brake line has correct air pressure up to the last wagon. This air brake line should be continuous, and it is of utmost importance that the air brake line is uninterrupted, otherwise the train won't handle properly. For example, if the train is moving and for some reason the continuity of the air brake line is lost somewhere along the train, the locomotive will only be able to release air out of the air brake line to the point where the continuity is lost. Only the front half of the train, which has now reduced its air pressure, will be applying brakes. Because brakes can't now be applied to the rear half of the train, the momentum of the rear half will still be pushing the front half forward. This can cause the train to derail or overshoot into a section with an oncoming train, causing a major accident because the train couldn't brake correctly. To prevent all this, the end-of-train telemetry system incorporates an emergency brake, which will cause the train to stop safely and in time. Normally, air pressure is only released from the front of the train if the driver wants to slow down or stop the train. In this scenario, where the air brake line has lost continuity, the EOT's emergency brake feature can drop air pressure from the rear of the train, braking the train from there as well, and avoiding a disaster. The emergency brake could also be used to stop the train quickly to prevent accidents. For example, when there is a car stuck on the tracks. Our EOTs are also fitted with GPS receivers and GSM communication devices. With these fitted, the following advanced features are included: train integrity, data logging, remote logging and tracking by means of GSM and GPS, and collision detection. Train integrity basically means that the train arrives at its destination in one piece and is complete. So, by means of a GPS receiver, in both the EOT and HOT, the train length can be determined before departure, and it is then displayed on the HOT. When the train length exceeds this value, the HOT will inform the driver. The HOT will also provide the driver with the speed of the EOT, as well as the speed of the HOT, and if there are any differences, the driver will be notified. All these notifications are aimed at ensuring train completeness. Both the EOT and HOT have internal logging capabilities. The following conditions can be logged: air pressure, speed, coordinates, and battery power. This data can be downloaded by means of a computer. Because the EOT has GSM and GPS capability, it can log valuable data onto a remote server as well, and track each individual EOT's current and past locations and routes. The HOT can detect other EOTs which are in radio range. It can then calculate the distance by which they are apart by means of each other's GPS coordinates, and whether the other train is moving away or towards it. The following optional features can also be included in the end-of-train telemetry system. These are derailment monitoring and an airgen to power the EOT. Derailment is detected by installing derailment detectors, or DEDs in short, on the rail. They are placed certain distances apart. When a train starts derailing and it passes the DED on the rail, it will detect that the train has started derailing and let the end-of-train telemetry system know about the derailment. An EOT which is mounted on the last wagon of a train uses a battery as its energy source. An airgen can be added as an infinite energy source. The airgen acquires its energy from the pressure in the air brake line. Thank you for watching this video. We believe that Inteletrack's end-of-train telemetry system will enhance your passenger safety and your financial investments. For more information, please visit our website and feel free to contact us.